to the stream, David and Mike. Let's do a round of introductions for everybody. Mike, you wanna kick us off?
Yep, sure. I'm Mike Hicks. I'm a senior principal scientist at AWS, and I'm the co-developer of Cedar, which is a language that I'm going to be excited to tell you about today.
And David, please,
Yeah.
your turn.
I'm David Nally. I run a group that's focused on open source strategy and engagement, and basically trying to make sure that AWS is ensuring that open source is sustainable. And part of that, obviously, is taking care of security.
Very nice. Very nice. So Cedar, I'm familiar with it from living in Austin. We get it every year. It causes cedar fever. But this is a different type of cedar, not the one that I'm talking about. It's a declarative language, right, for a permissions engine that was launched out. Mike, do you want to just like set the stage for us? I know we're going to see it in action, but do you just want to tell us a little bit about Cedar and why we built something like Cedar?
Yeah, sure. So these days, whenever you build an application that you're going to run anywhere, chances are you have multiple users, and you have some things that your application makes available that some users can see or modify or access, and some can't, which means that you have to implement a permission system for your application. And maybe you're thinking, oh, that's just code. I'm going to write that code like I write the code for the rest of my application. But a lot of people have tried that, and they find that over time, that permission system gets to be complicated. It gets all interweaved in your application code. And, it's one of the last things that you want to make a mistake on. So what we thought was you should separate your permission system as policies away from your application code. And you should make it easier to define what you mean in terms of what your users can do. And you should make it easier to maintain your application code by separating it from all those policies. So Cedar is our stab at that.
I love it. And I am one of those people that has tried to make one of these engines, actually, in a past life. I was talking with you both about this when we're prepping for the show. I do want to clear up, Anna. I could prove it wasn't me who said the comment about my karaoke skills. It looks like Ricardo.
Okay, 094459. That sounds very legit.
No, this is one of their friends. This is one of David's friends.
Yeah.
He's in here talking about my karaoke skills, David, not open source. I think you need to reprimand him.
So what you don't know is that Ricardo's a DJ, and he's really just trying to egg you on so that he gets a shot on AWS On Air to perform as a DJ instead.
Ricardo's welcome anytime on
that
AWS.
Would be fun. We could do a little replay.
So his DJ name is DJ Tasty Taste.
No, I didn't know this about him. I knew he was a DJ, but I didn't know the name.
I will send you his Twitter. I will send you his Twitter later.
I cannot wait. Wow, this is incredible. All right, so pulling us back on the rails, which is usually not my job to do. I'm usually the one taking us off the rails. Anyway, I just to give the people maybe a quick example, I used to work in document storage, right? So, a lot of popular apps around that. I worked for a company called Box, Dropbox, another one, right? So this is a great, to me, example of permission systems, right? Like you have to know who can access these files that you're uploading. And sometimes in the case of something like Box, it's at like a folder level, it's at a individual file level, and writing the rules engine that goes in and says what user, if I upload a file to a folder that Anna can see, how do I on the application side go ahead and figure that out, that she can see it, right? Just because she has access to that folder. It's really complicated stuff to make this. So it's incredible.
And once you write it, you have to maintain it too. So that's a whole load of work that you might not want to do.
Yeah, for sure. So it's incredible that you all, made this and then open sourced it. So I want to turn to you, David. Do you want to talk about open source, maybe just in general at AWS, and then specifically why you all chose to open source this work with Cedar?
Sure. So, I don't think it's any secret that AWS is built on open source. AWS would not exist today if open source did not exist and if we had not taken advantage of it. So, the early days of AWS, we depended upon the Zen hypervisor to allow us to build out EC2. Even before that, we leveraged Apache Tomcat to build out S3 in the early implementation of that. And so open source has provided us a huge foundation. And so we have this vested interest, or some might call it a shared destiny, with open source. We're dependent upon open source. We care about that a lot. On top of that, our customers, they tend to prefer open source. A lot of customers that we talk to tell us that they have an open source first mandate, meaning that they are required to evaluate open source as part of technical product selection. And so a lot of times that just means that they're demanding open source as part of their solution. And I think in the past 18 months, the collective world has taken notice of something that I think I used to know. When I was, I've been involved in open source for 20 years, and I thought, open source is kind of mainstream and it's really everywhere. And I did not realize just how ubiquitous it was, and neither did the rest of the world. And about 18 months ago, there was a severe security vulnerability, Log4Shell. And suddenly the world realized that open source is everywhere. It's in your phone, it's in the phlebotomy machine that's analyzing your blood, it's in your refrigerator. And suddenly there's this huge recognition that open source is everywhere and it's important, and we need to be paying attention to it, particularly from a security perspective. Because again, we have that shared destiny, and when there's a huge vulnerability in Log4j, suddenly all of the Java stacks in the world end up potentially being vulnerable. So, we're AWS, because we have that shared destiny, and we're also trying to invest on behalf of our customers. We're constantly looking at how do we improve the security landscape for open source. And there's a number of ways that we talk about doing that. Mike's a great example of one of those ways, which is open sourcing our own security tooling. The things that help secure AWS and that are useful for us are probably useful for other places. That's not true across the board, because operating at the scale that AWS does, we have a lot of things that are pretty weird and unique and aren't necessarily applicable to everyone else.
You're talking about me, right? Weird and unique.
Well, I mean, I was talking about all of the Portland crew, right?
Yeah, that's Anna over there for sure.
But that was actually a slide at Austin, I guess.
Fair enough.
But so we're those weird things, maybe aren't applicable to everyone else, but there's a lot of things that we can do, and a lot of tooling that we have to build to improve security at AWS, and this is a great example of one of them. Cedar's something that when it first was being proposed. So there's a process where teams at AWS write PR FAQs, and when I read the PR FAQ, I'm like, I don't know why we're doing this. There are existing policy engines. What is so different about this that we should go and invest and do something that's different than what already exists in open source? And the team that Mike's on really helped educate me, to help me understand. And I won't steal his thunder to talk about Cedar, but definitely releasing some of our security tooling so that other people can take advantage of it. There's some advantage for our customers in being able to leverage some of the expertise, and it's a deep expertise. As a matter of fact, I'll geek out just a little bit. So one of the features around Cedar is that it makes use of automated reasoning, in that the engine itself can be formally verified, and I will, as a non-scientist and non-mathematician, attempt at that, and then Mike can correct me. But this idea of using math and math proofs, logic proofs, to verify that the engine does what it says it will do. And we think about, especially if you're a fan of test-driven development, we think about putting unit tests in and integration tests and testing a code base as you're developing it. This is a step further. So typically when you're writing unit tests, you're verifying that things work as you think they should in small chunks. When you're doing integration tests, it's a little more larger surface area, and you're typically testing happy path. If you're really advanced, you're also going to test some failure modes to make sure that they indeed fail as you expect them to. But what formal verification does is it uses logic to test any number of potential outcomes and actually verify that it works as it is supposed to across a range of things that can be logically applied. And
so you're getting the edge cases as well, which is usually what some tests can miss.
Exactly. And at AWS's scale, we see lots of edges. Just think about the magnitude of the number of different people doing different things, and at AWS's scale, and it's massive, and people come up with weird ways to break things all the time. And so this is using math and logic to give you a much greater assurance. And I am not a mathematician. It actually scares me sometimes to talk about automated reasoning because I have never used it in anger, but I see the outcomes of it all the time, and it's amazing. So, Mike, I'm sure I butchered that. Is there some?
Yeah, I think this is a great intro. I wanted to also, just before we dive in, because I think this all comes together once you actually see it. And Mike's got such a wonderful way of showing us this in action that I want to get to. But I think this is I had a little stint in security. I was actually working for a security company when Log4Shell happened and Log4j happened, and a lot of that fun stuff went on. But this has been a long road for security, doing things in the open, right? Like this has a lot of basis. I was talking with Ken Beer at Reinforce on this very show about encryption algorithms and, moving encryption algorithms to be open and verifiable and researchable by people that can research those things has done nothing but improve the security of all of these systems, right? I think people don't realize that necessarily. They may, if they haven't worked in security, look at something like this and go, well, wouldn't it be better if we kept it secret? Like if we didn't expose this publicly, if we just didn't have any way of people knowing how the system worked already. And oftentimes that makes it severely less secure in some respects. So,
right. Especially when something goes wrong and you don't know where to start.
Yeah, you have people looking at it constantly and reporting. There's a whole ecosystem out there about reporting vulnerabilities, and this is how Log4Shell got discovered, right? It would have never been discovered potentially if it were just some proprietary piece of software out there that only 6 people ever got to look at. So I wanted to pull up just as a quick intro for you, Mike, before we jump into your demo. We've got people writing some Cedar in chat right now, denying Ricardo his appearance as DJ, or giving it to him. Nope, forbid. I see forbid. Never mind. All right, so Mike, you with that intro, do you want to take us through what it looks like building an app with Cedar?
Absolutely, be happy to.
Let's bring up your screen and let's see.
All right. So, like I was saying before, you would like to, let's suppose you want to build an application and you have a permission system for your application. So the demo I'm going to show you is for a task manager that we lovingly call Tiny To Do. Here's how you might have built Tiny To Do before Cedar. You build a server, it's a web service, and your clients are going to send HTTP commands to your service. It's got all your data and everything else. And inside of your service logic is mixed in all of your authorization logic as well. It's the when you get the command to look at a particular file, you also inside the logic for retrieving that file include logic to make sure that that retrieval is okay. And over time, that's where you run into trouble because it's difficult to tell what is exactly your security posture, where does your application code end and your security code begin, and that maintenance problem comes to the fore. So this is what it would look like if you use Cedar instead. And this is what we're going to see in the demo. Your server will have the Cedar authorization engine linked into it. When commands come in from the client, so in the case of Tiny To Do, somebody wants to create a task list. Maybe they want to check off a task on the task list. Maybe they want to share it with one of their friends. Instead of just doing all of the security checks inside of the application code, the check is going to go to the Cedar engine there in the circle, and it's going to consult Cedar's policies stored off to the side to see whether or not you're allowed to perform that action. And if you are, great, it'll go ahead and continue on and do that. Otherwise, the denial will result in an error message going back to the client. So this is going to give you the advantage of those policies are in one place. Cedar policies, I think you'll see for yourself in a moment, are easy to read and pretty easy to write as well. Because you can see them all together, you can think through what is it that those policies really mean? What do they imply about my security posture? And also I'm going to show you we have some tools that help you debug your policies so that you don't make security mistakes. And as of course we've been saying, that all of this is open source. It's at this GitHub site. And in fact, all of that automated reasoning goodness that David was talking about, all of our proofs, also the intensive tests that we do to make sure that we're proving the right things, are all in that open source repository that you can look at yourself. And of course, we welcome contributions, and we've been very happy to be taking contributions from the community for the last couple of months since we've been open source. Okay, so now I'm going to jump to the actual demo. So as you saw on that last slide, for the demo, the client is a little Python client that's sending HTTP requests to the server. So I'm going to start that up. The environment variable that I set there, Rust log, is a logging system so that we're going to be able to see the requests that are going to and from the Cedar engine, so we can explain how Cedar is playing a role. I'm going to start up the server here, and there's a couple of those log messages that's just saying that things are starting up. Okay, so the first thing I'm going to do as a client is I'm going to set myself to be a user, Andrew. When I started up, I read in a sort of a user file of all of the users that have already been configured just for demo purposes. And so Andrew is one of those users. Normally right now, you would imagine authentication would happen. We would type a password and stuff like that. Since we're worried about authorization, who can do what, not who you are, we're not worrying about that for the purposes of the demo, but obviously in a real app, you'd want secret keys and passwords and everything else. Okay, so now as Andrew, I want to create a task list. So I'm going to say, yep, I want to create a demo here. And what do we see? Well, creating a task list is a protected operation. And so Cedar is going to be consulted. Is this actually okay? And we can see the request here in the log message, which says user Andrew is asking whether they can create a list for our application, Tiny To Do. And the authorization response is allow according to policy 0. Okay, so what's policy 0?
Yeah, where'd that
come from? Let's have a look at the Cedar policies. So we can see this file right here, policies.cedar. It contains those files that are policies that we saw that were off to the side in the diagram there. And this is policy 0. And policy 0 says any principal is permitted to perform either the action create list or get lists for the application Tiny To Do. Okay, great. That makes sense. Andrew is a principal wanting to perform create list for this application. And so sure enough, this is allowed. Great. And we can see here list 0 was created. All right, so now Andrew is going to, let's try that again, is going to create a task for the task list. So the first argument is the name of the list, that's list 0. And then the second argument is the name of the task. Okay, well, what happened? Andrew asked, can I do this? Can I create a task for list 0? And the authorization response is, yes, you can. And this is according to policy 1. Okay, well, let's look at policy 1. Policy 1 says, any principal can perform any action on any resource when that resource has an owner, and the owner is the requesting principal. So in this case,
sensible.
Yep, Andrew is the owner, and Andrew was the one asking to create the task. So awesome, Andrew's allowed to do that. So let's do another task. Why my thing goes that way? And let's flip a task, and let's see what our task lists look like. Okay, so I did all of those things. I checked the task, and all of those things that I asked to do, they're all authorized by policy 1 because I'm Andrew, I own the list, I can do whatever I want. Well, what happens if I'm not Andrew?
Yeah.
Okay.
No tasks for you.
Let's see, a permission system is not very interesting if it doesn't deny permission every once in a while. So now I'm user Aaron, and let's see if Aaron can get the list the way Andrew just did. And in this case, the answer is no, your access is denied. So here's that request again. I'm calling get list on list 0, and I, in this case, is Aaron. And then the response is deny. And in this case, the reason is empty. So what does that mean exactly? Well, what it means is that Cedar is a default denied language. If there is not a specific policy that authorizes action, then by default, you're denied access. And so of the 4 policies, we've seen 2 of them that we have, none of them was sufficient to provide Aaron access to read the list, and so Aaron was denied access. So
that's the opposite of star permissions, basically.
That's right. So let's see now what the other 2 policies look like that are not helping Aaron. This is the next one. It says that any principal can perform the get list action, which that was the one that Aaron wanted to do, as long as that principal is a member of the resources, readers, or editors groups.
Oh, cool. So you can have groups in terms of like users, groups. Those can be the principals. You're not just relegated to users only.
That's correct. So the Cedar data model allows you to have attributes that are associated with particular objects. So in this case, readers and editors are attributes of the resource. We call them entities. And those attributes, in this case, point to groups. So the in operator says that this principal is a member of this particular group.
Very cool.
So a reasonable question that you might have is, well, how do you get to be a member of that group? How does that group get populated? Okay, well, we can do that if we're Andrew. If I switch back to Andrew, I can share my list 0.
Andrew sure has a lot of power, Mike. Kind of worried about Andrew a little bit. He might.
Andrew is power hungry. You can just you see the hunger in his eyes. Okay, so he shares the list. Okay, great. That's the edit share action. And this time, again, policy 1, Andrew's the owner. He has the power. And now Aaron is a reader. So if I go back to being Aaron and I do get list 0 this time, hey, I can see the list. And why can I see the list? Well, policy 2, that policy we were just looking at, because in sharing the list with Aaron as a reader, Aaron is allowed to get the list. But Aaron is not allowed to check off one of the tasks in the list. That's access denied. Being a reader allows you to get the list, but if you wanted to be able to make changes to it, you either have to be the owner or you have to be in the editors group. And this update task or create task and so on require you to be in those groups. So this is sort of how things go in a nutshell. If we step back and think, well, what did we gain from this? Why was this a good idea to do Cedar rather than mixing it all into my code? Well, first of all, I hope you might agree that doing it in Cedar, these policies are not so hard to read. I can write this out in pretty readable syntax. It rolls right off the tongue how to interpret what these policies are. And if I sit and think about it just for a minute, I can think about what all of them mean together. They're not kind of here and here and here and here in my code, which makes me wonder as I scan through all the code, what's going on there. Another benefit is that in looking at the code itself, it makes your application logic simpler. So if I go to the rest code here, let's see.
You don't have to mix in permissions with the rest of your logic.
Exactly. So if I delete my terminal there, okay, so I can see here, these are the handlers inside of my web server. And the beginning of every one of the handlers for these commands, you can see starts with this call is authorized. And what it's doing is it's passing in the principal, action, and resource that we were seeing in those logging messages. What happens next is all the logic for the particular handler. It's separated. You do this one thing, you intercept the call, you do the authorization request. If I come here to the bottom, this is that one call. Here are those logging messages that we've been seeing. And here's the invocation of the Cedar authorization engine. It's passing along the request, which has principal, action, and resource. It's passing along those 4 policies that we saw, and it's passing along the relevant application data. When we get either allow or deny as our decision, we're able to then proceed with that request. So this separation of concerns makes it easier for me to modify my application and modify my policies. For example, if I were to comment out this policy or comment it back in so that the admin team can do whatever they want, and I save it, if I flip back to my terminal, you can see that the terminal reloaded the policy set. And if I set myself to be user Amina, remember, I didn't explicitly share with Amina. When I did this for Aaron and I did get list 0, it didn't work. But if I do get list 0 for Amina, because she is a member of the admin team, no problem, she's allowed to get access. So you're able to make those changes independently and have that nice separation of concerns. If we have time, the last thing I want to show you, if possible, is how we can use policy validation to make sure that your policies don't have mistakes in them.
Yeah, let's check it out.
All right. Yeah. So what if when I was adding this policy here, I had made a mistake? What if I mistyped team as TAM? Well, when I go to save that, I get these nice little squiggly lines which say something is wrong here. Unrecognized entity TAM, did you mean team? Or, let me fix that. Suppose when I was typing in this policy, I did GT list instead of get list. Okay, well, the validator is giving me a helpful suggestion that maybe you meant a different action instead. Or maybe I forgot that in was the right operation for checking membership in a group, and I tried to do less than. The validator is going to say, no, I'm expecting a number here. This is only for numeric comparisons, but you're giving me a user on this side and you're giving me a team on this side. So that doesn't make sense either.
That's great.
So how does it know how to make those distinctions? Well, what you do is you write, like you would in other settings, something that's like a JSON schema for your authorization posture. You define the different types. We've seen users and teams and lists, and we saw in lists, for example, that there's owners and readers and editors. And so you describe the shape of your data. When I typed in TAM and not team, the validator could tell, whoops, that's a mistake. Probably you meant this one. And likewise, in the second part of the schema, we list all of the actions that make sense for our application. This way, when you mistype an action, which will result in not the authorization decision you wanted, the validator is going to catch you before you deploy that policy and say, no, you meant this other action instead. And not only that, you can tell the validator what kinds of data you expect to be coupled with those actions. So again, you don't make mistakes when you make those authorization calls. So this is another way that in separating your policies from your code, you get some extra checking to make sure that you wrote the policies in the way you intended, rather than, oops, I made a coding mistake and there's nothing that's going to help me fix that. I just have to notice it, hopefully in a test or something like that.
Mike and David, we've got a question from chat. I'm going to do a little interpretation here, but I'll put it up here. Is it possible that Cedar file could be more dynamic, like a database table? So I'm assuming from this question, and please tell me if I'm wrong here in chat. Can you programmatically alter Cedar policies right through your application logic?
Absolutely, absolutely. So here in the code, I'm passing in these policies. I happen to read them in from a file, but frankly, I could store them anywhere, and I could do just as you say, create them on the fly. Cedar has something called templates that are very much like prepared statements, where a template has holes in it, and you can fill in the holes with pieces of data to instantiate, to link to a particular policy. So we definitely have application scenarios where you are creating policies on the fly by just instantiating these templates, and then you pass those in.
Very Super cool. Very, very cool. And like I was saying earlier, this is not easy to build yourself. I know from experience, this is really, really difficult to build and get right.
Well, and have features like validation. That's great. I mean,
Yeah.
I live or die by red squigglies in my VS Code, so it's so nice to have that built in.
For sure.
It's one of the points that David brought up about the automated reasoning. What is it that you're showing is actually correct that's going to work all the time? And one of the things we show is that validation algorithm actually gives you a guarantee that if the validator says, yep, your policies are valid, you can be assured that they will not fail at runtime. They won't mistakenly try to check that a number is a member of a user group. They won't try to invoke an action that's of the wrong type. And we use this automated reasoning capability to prove that the code we implemented for our validator 100% of the time satisfies those conditions. So it's our way of realizing that people want to have a lot of assurance that their authorization system really works the way they intend, because it can be protecting some important information for them.
Yeah, we got to wrap up here in just a minute or two. I wanted to just, for anybody who's new to identity in application development, one of the hardest parts of developing an application is identity, right? And so I just wanted to give Mike and David a chance to, we mentioned a few terms here. We said authorization. Mike also mentioned authentication. There's a big difference between those two things, right? Authentication is not being handled by Cedar, right? Cedar's handling the authorization side. Mike, I loved you dropped it through your demo. Can you give us again that it was like a one-liner about auth in versus auth z? That's how people will shorten it sometimes too.
Yeah, absolutely. So authentication is assuring that you know who you're talking to. And authorization is, now that you know who you're talking to, making sure they only do what you intend them to do. And authentication is a super hard problem. We're used to passwords or whatever, but then came multi-factor authentication, then came crypto keys and security, and protocols and OAuth and all this stuff, right? So once you've done authentication, it feels like, oh, I'm done. But no, it's
just
not
getting
so
started.
Being able to say who's allowed to do what once you know who is still a big lift.
It sure is.
Yeah,
sure is. Yeah. Well, great. It looks like you've got the GitHub page up here for Cedar. Go check that out. Mike and David, I'm gonna take your screen down so we can all see everybody. Any parting words for the audience other than go check out the GitHub?
So I will. Mike and his team have a great blog post up about Cedar with links to demos. And if you want a fast on ramp to understanding and seeing Cedar used in a couple of examples, those are great. Those are actually stored on GitHub, so you can easily access them. I'm blown away by what this team has done in terms of not just writing an authorization engine, but in showing the work so that our customers and the users of this can validate it for themselves, and then knowing that this is actually being used in some AWS services for authorization as well. And so this is as much a show your work as it is enabling other people to go take advantage of it.
I love it.
Absolutely. It's been a really awesome ride, and we would love for folks to join the Cedar community. We're taking pull requests from people already, asking for language features. We want to make the authorization engine that's going to work the best for you.
Very nice. Perfect. Go check out Cedar. Go get those PRs in. Go get some feature requests in too, sounds like. And Mike, David, I hope to see y'all again. You're welcome back anytime, of course.
Thanks for having us.
Thanks so much. Enjoyed it.
We'll see y'all next time.